The structure of the benzene is studied in this concept. The structure of the benzene is considered planar structure, means it's a flat structure. The point comes in this point, planar structure is, it is a hexagonal in a shape and all carbons are sp2 hybridized. This structure shown here, this diagram shows carbon, carbon, carbon of benzene, 6 carbon total, and these are the orbitals. Now these orbitals are overlapping, so the sigma bonds are formed. So 1, 2, 3, 4, 5 and 6. 6 sigma bond with the carbons, and this is sigma bond of carbon with hydrogen. So sigma bond of carbon, carbon, sigma bond of carbon, hydrogen. This makes this skeleton, this structure flat. All the carbons are sp2 hybridized. So this is a flat structure. The point number 1 is the flat planar structure, hexagonal shape. Point number 2 is the carbons unhybridized p orbitals, they are perpendicular to the plane. In this structure, the carbon-carbon sigma bonds are shown. Here, what you are seeing is the carbon-carbon sigma bond and these orbitals. These are the unhybridized p orbitals of carbon, which is having one electron. So these are arranged perpendicular to the plane of carbon. This flat plane, this is perpendicular, and each p orbital contains one electron, therefore they can overlap, and thus they can form a pi bond, 3 pi bonds. So carbon, you see here the bond p orbital, they can laterally overlap and they can form pi bonds. Now these pi bonds, these pi bonds, 3 pi bonds are not fixed, they are delocalized, means the electrons are moving in the ring. The position of pi bond is not fixed, it is rotating, that we saw in the resonance. So this is the next point, that pi electrons are delocalized. And because they are delocalized, they will form an electron cloud on and below, above and below of the ring. So this is p orbital, electrons are there, and because they are perpendicular, so it seems as if the cloud, electron cloud is there of electrons of pi bond of benzene above and below the skeleton of benzene. Okay. Next point is molecular orbitals. There are two kind of molecular orbital, bonding orbitals of benzene. Bonding, 3 bonding molecular orbitals and 3 anti-bonding molecular orbitals. The bonding orbitals of benzene are of lower energy and therefore having more stability, and anti-bonding molecular orbitals of the benzene, they are having higher energy and therefore less stability. The benzene's 6 pi electrons are involved in the formation of bonding molecular orbitals, and therefore benzene is stable structure. Then the bond between carbon-carbon of this benzene, even though we show like this, double bond, single bond, alternate, this is actually hybrid in between double bond and single bond. The bond length of carbon-carbon is 139 picometer. All the bonds of carbon carbon are 139 pm. Generally, the carbon carbon double bond in alkenes is 134 pm. So it is higher than double bond, and carbon carbon single bond length is 154 pm in sp3 hybridized carbon. So it is less than carbon carbon single bond. So it is, these bonds are hybrid bond in between the double bonds and single bond, and bond length of all the carbon is same, that is 139 pm. As far as the bond angle is concerned, bond angle is 120 degree between carbon carbon also and carbon hydrogen bond also. So this is the molecular structure of benzene.